Okay, so we have come to the exercises on this section, shifting graphs, and as we have already discussed before, we are not going to solve all the exercises here because they are very similar to one another. So what we will do, we will solve only 3 of them, and from these solutions you will get the ingredients to solve the others. So the others are left to you to solve for yourself. They are practice exercises. So in this one, we are going to start with this one, exercise 37. We are given a graph of some function y equal to f of x. What function that is not given, only this graph is given, which the shape of the graph roughly looks like this. It's a bell-shaped graph which lies between the values 0 and 2 on the x-axis, and on the y-axis it lies between the values 0 and 1. And from the shape of the graph you have to understand, although I have not been able to draw it properly, that it is symmetric with respect to this vertical line x equal to 1. And now what we have to do, we are given these new functions defined in terms of the old function f of x. In each such case, we have to find the domain and range of the new function and also draw its graph. So let us start the solution. So in part A, the new function is the old function plus 2. That means we are increasing all the old y values by 2, by adding 2 to them. So naturally the graph will go up, the new graph will go up, or rather I should phrase it like this: the old graph will go up by 2 units and make the new graph. So it will look like this. Let's draw the graph. So these are 1 and 2 on the x-axis, 1, 2 and 3 on the y-axis. So you can understand that this point lies on the line x equal to 2, and from the original graph we can see that the graph gets its peak at the point x equal to 1. So this peak point has the coordinates 1, 1, and now that peak point has coordinates 1, 3. So this is our new graph. And we are not going to write much. I mean, of course, in the solution you have to write all the things, all the formal things, that the following is the graph of the new function f of x plus 2, and then you draw the graph. And now we have to discern what its domain and range are. So the domain and range are, of course, the domain is the set of the x coordinates of the points on the graph. So looking at the points on the graph, their x coordinates lie between 0 and 2, like what you have originally. For the original graph also, the points have their x coordinates lying in the interval 0, 2, and each point in the interval corresponds to a point on the graph. So here also, the domain of the new graph is 0, 2, and the range, like the domain, is the set of the y coordinates of the points on the graph. Previously the range was the closed interval 0, 1, now it is the closed interval 2, 3. You can also understand, without looking at the graph, just from the formula itself you can understand that the domain does not change, it has not changed, because we have not done anything to x here. We have done something to the y values. We have added 2 to all the y values. So the domain stays 0, 2, but since we have added 2 to all the y values, the range has been shifted from 0, 1 by 2 units to 2, 3, 1, 2. Okay, so this is the new range. Then B. Here you can understand, there we had +2, so the graph has gone up. Here we have -1, it will come down, and by 1 unit. So let's draw that also. So for part B, we don't have to keep much space above the x-axis. One, two, -1. So here the graph will be this 1, 2, -1, because now all the y values have been decreased by 1. And now looking at the graph like before, here also the domain has not changed. The domain is still 0, 2, because all the x values of the x coordinates of the points on this new graph are still, they form this interval, but the range has changed from 0, 1 to -1, 0. The previous range has now come down, has been shifted by 1 units down. Then C. In C, we are no longer adding or subtracting values from the y values. We are multiplying the y values by 2. So we are doubling all the previous outputs. and this doubling has the effect of stretching the original graph vertically. Okay, so the new graph now looks like this. Of course, I am showing you the rough shape. Every time I am drawing, I am changing things, obviously. Changing things means I cannot draw a perfect graph freehand. 1, 2, 1, 2. So previously the value of the function at x equal to 1 was 1, now it is 2. So here the domain is still the same, but the range has now been stretched along the y-axis by a factor 2. So the new range is the closed interval 0, 2. So now the domain and the range are the same set. Then D. In D we are taking the negatives of all the previous y values. So that means we are bringing all the we are reflecting all the previous y values on the x-axis. So previously if this is the x-axis, this was the y value. Now we will take its reflection on the x-axis. So now the graph will look like this. Okay, it was like this, it has been flipped about the x-axis. So this is 1, this is 2, this is -1. The domain is still the same, 0, 2, but the range has changed. It is -1, 0. Note that these two functions, the functions that correspond to these two graphs, they are different functions, but still they have the same domain and same range. That of course can happen. Next, E. And now the domain will change. So far whatever we did with the y values. We did not touch the x values. F of x, that argument of f still stays x, in each case, each of these 4 first cases. Now the inputs will change, now the arguments will change. However, you can see that we are not doing anything to the y value in this function. So here the range will not change, but the domain will change. So what we have done, we have added 2 to all the original, we have added 2 to the original input. And what effect does it have on the graph? The effect is that the graph will be shifted horizontally by 2 units to the left. We discussed all these things in general in the section. So now this is the situation. -1, -2, and this is still 1. So you can see that the range has not changed, it is still the closed interval 0, 1, but the domain has changed. Now the domain is -2, 0. And the range is still 0, 1. Questions may arise on your mind about the graphs we are drawing, right? For example, in the other cases it's okay, we are shifting the original graph. In this case, however, the shape of the graph has changed. Shape has changed, of course, the size has also changed, and we said that we are stretching the original graph vertically. Now the question that may arise on your mind is, when we do such a stretching, how do we know that the original shape, the very statement that we are stretching the original graph to form the new graph, how is that justified? These things can be answered and will be answered, but not right now. What I am trying to say here is that, how do we know that we have to stretch? Say you grab the original graph by its peak and you then move upwards, you pull it upwards. So whatever happens to the graph looks like the original graph itself, but a stretched version of it. How do we know that? Okay, we will answer these things later on. And one more question which is more important is this: when we are stretching, say, assume for the time being that we can actually this amounts to stretching and we do get such a shape. But now the problem is, fine, you are stretching, what is the guarantee that the graph will not break? It will stay in one piece like before. And that, of course, is something that we will definitely answer if the things are coming. It has to do with the continuity of the function. Okay, those things will come in due time. Right, so we have done the part E. Next, F. So here also the domain will change, and because we are subtracting 1 from x from the input, so this time the graph will get shifted horizontally towards the right side of the x-axis, towards the positive x-axis by an amount 1 unit. So previously it was like this, now it will be here. 1, 2, 3. Okay, so this is the graph. You can verify some things, some small things, to see that what you have done is correct. The new graph looks like this. If you put x equal to 1, you get f of 0, and the original f of 0 was 0. So yes, you are getting 0 at x equal to 1. Like that, if you put x equal to 3, you get f of 2. Originally f of 2 was 0, so this one is also 0. And if you put x equal to 2, you get f of 1. The original f of 1 is 1, so you are getting 1. So yes, the graph has been shifted actually. And here the domain is 1, 3, and the range has not changed. It is still 0, 1. The range will not change in these two cases because we have not done anything to f as a whole from outside. What we have done is to the inputs x's on the inside. So before drawing this one, you can imagine that here also the domain will change, but the range will not change. So for part G, what we are doing is we are taking the negatives of all the previous input values. So note that whatever we are doing to x here is somewhat similar to what we did to f of x here. We are multiplying f of x by 2. Here we are multiplying x by -1. So these two cases are not exactly translation of the graph. So the previous domain was 0, 2. Now we have reflected it on the y-axis. Now it is -2, 0. All the original inputs in their places, we are now taking the corresponding negative values. So there is actually a difference, although the okay, let me just first draw the graph, then I will say what I want to say here. You can see that these two graphs look the same, and they are the same. They ultimately will give us the same function. However, the subtle difference is that, you see, previously what we did, so what I am talking about here is the comparison between this one and this one. So previously what we, okay, will they really be the same function? Actually it's, I mean, that is not a priori given. It is not always necessary that these two are the same function. That is, it's not necessary to have this, but from these two graphs it looks like they are the same function. The reason for that is the symmetry that this graph has about this line that vertically passes through the middle point of the graph. So what I am trying to say here is that this means what? X plus 2 means translating the domain by 2 units to the left. This, however, means something else entirely. It is reflecting the domain about the y-axis. Okay. So our original 2 in the original domain has now become minus 2. However, our original 2 in the original domain in this case has become 0 because this is translation. In general, if you don't have this symmetry, then these two, there is no reason for these two graphs to be the same. Do you see why? When you are having this original domain 0, 2, you have the graph like this. So for example, not these points, say 0 or 1 or 2, but some point in the middle. Say your graph is not symmetric, it is like this. Originally, if this was the shape of the graph, then this translation will just translate the graph like this. It will now look like this. However, this one is a reflection. So this one looks like this. In this case, because you have the symmetry, it looks like we have got the same function. And yes, we have got the same function, but that is only because of the symmetry. In general, that is not necessary. Okay, these are two different things. Anyway, so that is the difference. So let us write the domain and range. They are going to be like that part E, identical. Domain is minus 2, 0, like here, and range is 0, 1. And finally we have come to H. In this part we are changing the inputs as well as the outputs. Okay, so the two types of translations are happening simultaneously. So we are shifting the graph horizontally also because we are adding 1 to the input values, and at the same time we are shifting the graph vertically because we are adding 1 to the output values, but there is something else additionally. We are not adding 1 to the original output values, but they are negatives. So it involves everything. It has been carefully chosen by the authors. It involves horizontal translation, then reflection, and then also vertical translation. So you can guess what is going to happen ultimately. This is our original graph now. So what x plus 1 will do is that it will shift the graph to the left by 1 unit. So f of x plus 1 is this. Then you take the negatives of all the y values, that amounts to considering the reflection of this graph on the x-axis, and then you add 1 to that reflection, so that moves the graph up by 1 unit. So the final graph will look like this. Okay, so in that way you can guess what the final graph is. So let us draw this graph. It's going to look like a trident along with the y-axis. Oh, and one more thing, when you write these solutions, you have to write those things that, since we are, for example, here adding 2 to the y value, so the original graph is obtained by shifting, the new graph is obtained by shifting the original graph by 2 units towards the positive y-axis. Those things have to be written. So here you have to write those steps. You can write this thing in 2 or 3 steps, like the graph of f of x plus 1 is obtained by shifting the original graph by 1 unit to the left, and then you reflect that graph on the x-axis. You get the graph of minus f of x plus 1, and then you add 1 to that function. That means taking that new graph to this new position, move it up by 1 unit. So that's how you get the final graph. And here this is minus 1, this is 1, and oh, I have to write it here, no? This is 1. So here both the domain as well as the range, they have changed. This is our new domain. Oh, range still has not changed, okay. Because of the shape of the graph, it looks like the range has changed, but no. After going through all the intermediate steps, ultimately we have come back to the range 0, 1. So that's just it. This is the solution. Now after this, we are going to solve these 2 exercises. There is no particular reason to choose these 2. I have just randomly chosen 2. Shifting lines, these involve no drawing. If you want, you can of course draw for your own understanding. The line y equal to mx, which passes through the origin, is shifted vertically and horizontally. Vertically and horizontally to pass through the point. X naught comma y naught. Find an equation for the new line. New line, and this equation is called the line's point slope equation. Is called the line's point slope equation. So we are given a straight line y equal to mx, where m of course is some constant, and we already know from our studies on straight lines, I said straight line, that this type of lines pass through the origin, and this line is shifted vertically and horizontally. You do whatever you want to do, what kind of shift you want to do in order to bring the line to a position where it will pass through this point. Now we have to find the equation of this new line, and this new line is called, whatever equation we are going to find, that is going to be called the line's point slope equation, because you can see one thing. This line has slope m. Whatever you do, whatever type of shifting you do, whether you shift, say this is your line, you want to shift horizontally the line, it will go like this, it will take a new position. You want to shift it vertically, it will go like this. That slope does not change. So in the new position also the slope is going to be m, and it will now, instead of passing through the origin, it will not now necessarily pass through the origin, but through this new point. So the new equation is going to be called the point slope equation of the line. Now note that this equation, this general equation here, we are saying that m is a constant, but m is an arbitrary constant. You can take any real number in place of m, and once you choose a real number, you get one straight line passing through the origin. Now this equation takes into account almost all straight lines passing through the origin except one, which is the vertical line, that is the y-axis, whose equation is x equal to 0. For no real number m, can you make this equation this equation? Okay, so that means because of the fact that m is a real number and not infinity, this line is not, it does not represent a vertical line, and this has implications. Since m is a real number, the line y equal to mx is not vertical. You can make this line very steep by choosing a large value of m. You choose larger and larger m, the line will be steeper and steeper. I'm saying the positive m's because the negative m's will be like this. So if you have a positive real number m and there you said you take m equal to 10, the line will be like this. If you take m equal to 100, the line will be like this. So it's very close to becoming vertical, but still for no matter how large m is, no such value will make this line vertical. And now because this line is not vertical, so it's enough to shift this line vertically to make it pass through this point y. So your line is like this. So no matter, okay, so let me just draw a figure. I said we won't draw any figure, but still for the sake of understanding and clarity, so this is our line and it does not originally pass through this point, which is also an arbitrary point, it can be any point. So this point does not lie on the line, assume that. The point will either lie below the line or above the line. These are the two possibilities. Wherever this point is, it will either lie below this line or above this line. And because the line is not vertical, no matter how steep it is, this is the case. So you don't have to do any horizontal shifting. Just a vertical shifting by some amount will make this line pass through this point. If the point lies above the line, your shift is like this, it's a vertical shift. If it lies below the line, your shift is like this. Only for a vertical line this will not work, because if your point is, then the point which does not lie on your line, either it lies to the right of the line or to the left of the line. Now vertical shifting does not mean anything because the line is extended indefinitely on either direction. So vertical shifting does not do anything, okay, but you have to do horizontal shifting in order to make this line pass through this point, wherever the point is lying. That we don't have to do now, because the line has some slope, not infinite slope. And that is why, because only a single vertical shift is enough, in the modified equation of the line, We just have to add one constant to the y value, that's all. We don't have to do anything to the input values x. So after a vertical shift, the equation of the line is y equal to mx. This is the y value, this is the y value, this is also the y value. The y value now is changed by some constant d, where d is some real number. Now if this new line, we can call it a new line, but because we are interpreting it as the old line in a new position, so let us not write new line. If the line now passes through this point, then of course these coordinates will satisfy this equation. Y naught is equal to mx naught plus t, or t is equal to y naught minus mx naught. So you now know what d needs to be in order to make the line pass through this point. Hence the new equation is y equal to mx plus d, d is y naught minus mx naught, or y is equal to, or we can take the y naught on that side, y minus y naught is equal to m times x minus x naught. This is the point slope form of the equation of a line whose slope is m. I already said before that the slope is not going to change, and which passes through the point x naught comma y naught, which you can now see from this from the form of this equation, the way it has been written. If you put x naught in place of x, you get 0 on the right side, you get 0 also on the left side if you put y equal to y naught. So it does pass through the point x naught comma y naught, and of course its slope is m. So here the solution ends. And there is another one similar, we will solve that one, and that will be all from this section. So that one is going to be 74. the line y equal to mx is shifted vertically. To pass through the point 0, b. What is the new lines equation? Now that we have the point slope form of the equation, we can directly write the equation. The equation of the new line is y minus y naught, y minus b equal to the slope, which is m, times x minus x naught is 0, or y equal to mx plus b. So that is the equation of this line, which has slope m and it passes through the point 0, b. This equation also has a name. It's called, I think, slope intercept form of the equation of a straight line. So that will be all from these type of exercises. In the next calculus video, we will start trigonometry, and then we will see the things that come after that. After trigonometry, is this preliminary chapter going to be over? I can't remember clearly, but we will see. And today is what? Today is Tuesday, no? So coming Friday we have a number theory video. We are going to have a number theory video. So that's just it in this video. If you want to say something, if you want to make a comment, you can use the comment section, or you can mail me at this address. So see you on Friday. Signing off for tonight. This is me, Lucifer, from A Mathematical Room. Have a nice night.